Next, I will show how to apply the Two Variances F procedure to test a statistical claim about two population variances. Consider the following example. A pharmaceutical company is about to launch a new manufacturing process in addition to the existing one. The quality control manager believes that the new method results in a different variation in the weights of the capsules. To verify the claim, the samples from each production line were obtained and the results are given. At 5% significance level, test the claim that two production methods have different variations. You may assume that the distributions of weights are normal in both production lines. First, let's note that the sample variances of the samples are 0.95 and 1.39 respectively, and the sample sizes are 7 and 10 respectively. Now let's identify the statistical claim that needs to be tested. The claim is that the variations are different. The keyword variation suggests that the claim is about the two variances, so we can symbolically express the claim as variance of the first production method is not the same as the variance of the second production method, which is equivalent to the claim that the ratio of variance 1 over variance 2 is not equal to 1. Since the claim is about the two population variances, we will use the Two Variances F procedure. Before we begin the Two Variances F procedure, let's check if all necessary assumptions are satisfied. The samples must be assumed simple, random, and independent. If not, then the results of the test are invalid. The populations also must be assumed normal. We will use the following template to perform the hypothesis testing. In step 1, we will set up the hypothesis. In step 2, we will identify the significance level. In step 3, we will find the test statistic using the formula. In step 4, we will perform either the critical value approach or p-value approach to test the claim. In step 5, we will draw the conclusion, and finally in step 6, we will interpret the results. Since our claim sigma squared 1 divided by sigma squared 2 is not equal 1 is in the form of an inequality, we are going to set it up as an alternative hypothesis. Therefore, the null hypothesis, which is always in the form of an equation, is set as sigma squared divided by sigma squared 2 is equal to 1. So the test is two-tailed. Step 1 is complete. The significance level can always be found in the statement of the problem. In our case, it is 5%. Step 2 is complete. The test statistic can be computed using the formula. In our case, the test statistic F0 is equal to 0.683. The test statistic F0. Next, we will test the hypothesis using two different approaches, the critical value and the p-value. In the critical value approach, we construct the rejection region. In this approach, we need to know the significance level alpha and the type of the test. We draw the rejection region under the F probability density curve with 6 degrees of freedom in the numerator and 9 degrees of freedom in the denominator, according to the type of the test. So a two-tailed test will have the rejection region in both tails. The region must have the total area equal to the significance level 5%. The critical values that define the rejection region are F 0.975, which is 0.181, and F 0.025, which is equal to 4.320. So the entire region can be described as all the values to the left of 0.181 and to the right of 4.320. In p-value approach, we compute the p-value. In this approach, we need to know the test statistic and the type of the test. We find the p-value using the F probability density curve with 6 degrees of freedom in the numerator and 9 degrees of freedom in the denominator, according to the type of the test. So in a two-tailed test, the p-value is the area outside of the test statistic multiplied by 2. Symbolically, it can be expressed as 2 times the probability of F being less than 0.683, which is equal to 0.662. In the critical value approach, we must check whether the test statistic is in the rejection region or not. Our test statistic is 0.683, and it is in between the critical values 0.181 and 4.320. Thus, it is not in the rejection region. In the p-value approach, we must check whether the p-value is less than the significance level alpha. Our p-value is 0.662, and it is greater than alpha. Both tests suggest that we do not reject the null hypothesis in favor of the alternative. Next, we are going to interpret the results. Interpretation. Under 5% significance level, we do not have sufficient evidence to suggest that the variances are different. The hypothesis test is complete. I just showed how to apply the Two Variances F procedure to test a statistical claim about two population variances or standard deviations.